You are welcome to this quick, short and concise lecture in preparation for Jamb UTME Physics. So what do you have to do? Observe protocol by tapping on this place that I'm hovering my mouse to enable full screen. Take this lecture on full screen. Also go to settings here, around here that I'm hovering my mouse. Choose resolution and choose at least 720p screen resolution to enjoy the maximum viewers experience. Do well to get your biro and your pen to jot down anything you understand in this video for your own good. I am giving you Jamb syllabus. This is the direct Jamb syllabus and I'm telling you what Jamb wants you to know. That's what I'm giving you now. So burn all your textbooks because you don't need them now. So I'm giving you what Jamb asks. So burn all your textbook. You are going to need them no more. Get your pen and your paper. Pause this video momentarily and jot down what you understand, what you see on the screen. Let's go. Measurements and units. And under measurement and units, what do we have here? The first we have here is the fundamental units. The fundamental units can be defined as basic quantities in physics from which other units are derived. So fundamental units are basic quantities or units from which you derive other units. It's like a mother unit that gives birth to other units. It's like a mother, the parent unit, the foundation that gives birth to other units. That's fundamental units. And they include length, which is measured in meter. Okay, length is measured in meter. Mass, which is measured in kilogram, kg. Time, which is measured in what? Second. Electric charge, which is measured in coulomb. Temperature, which is measured in Kelvin. Luminosity, which is measured in candela. And finally, amount of substance, which is measured in mole. All these are the fundamental units. Let's look at the derived units next. Derived units, they are units formed by combining two fundamental units. Remember that we just said that fundamental units are units from which other units are derived, or is the parent unit the basic physical quantities or units that gives birth to other units, or in which you derive other units from it. So this derived unit is defined as the units formed when you combine two or when you combine fundamental units. Is formed when you combine fundamental units. So they include area, which is measured in square meter, volume, which is measured in cubic meter or meter cube, weight/force, which is measured in Newton. That's when you have kilogram meter per second square. Okay, Newton, kilogram meter per second square. You know the formula for force. The formula for force is mass times acceleration. So weight/force. Okay, weight is also force. So weight is represented in kilogram. Okay, then force is the dimension. The formula for force is mass times acceleration. So you can see mass here represented as m, and mass times acceleration. Okay, acceleration is meter per second square. That's what you have here, meter per second square. So force, which is Newton, and weight, so kilogram meter per second square. So speed is measured in meter per second. So you can see that we have two fundamental units combined, okay, to form derived units. Here now we have meter and second. Both of them are fundamental units, one for length and the other for time. Here we have meter cube, meter times meter times meter into three places. That's we combine 3 meters to form meter cube. Here we have meter square, meter into 2 places. So that's it. Derived units, you combine two fundamental units, two or more fundamental units to form a unit called derived units. Now let's look at measuring instruments. The first measuring instrument we have here is meter rule, and it's the most common measuring instrument. And the meter rule measures length up to 1 meter. The meter rule measures length up to 1 meter. It's used to measure length, and it can measure length up to 1 meter. We have vernier caliper here, and the vernier caliper here measures small length. It's also used to measure length, but it's used to measure small length. It's used to measure diameters. It's used to measure depths. Okay, its accuracy is usually 0.01 centimeter, but when it's in millimeter, it's 0.1 millimeter. This accuracy is the zero error. Okay, zero error. You take zero error, 0.01 centimeter or 0.1 millimeter. The next we have here is micrometer screw gauge, and it's used to measure very small thickness/diameter. Very small thickness/diameter. That's why it's called micro. Micro means small, small, small. So micrometer screw gauge. Micrometer screw gauge is used to measure very small thickness and diameter when it's very small. What the vernier caliper can't pick, a micrometer screw gauge, we pick it, we measure it. The next we have here is measuring cylinder. It's used to measure liquid. That's it, and it's calibrated. The next we have here is stopwatch, which is also one of the most common because we use it every day. It measures time intervals. You know what stopwatch is used for. Then the next we have here is beam balance. There are different types of balance. We have the Bouchat's balance. Okay, we also have the chemical balance. So all these are what Jamb said you should at least know about them, what they are used for. They are used to measure mass. Okay, so the Bouchat's balance is used to measure mass. The chemical balance is used to measure mass. So as the beam balance. So you use Bouchat's balance to measure mass. You use chemical balance to measure mass. You use beam balance to measure mass. But when you want to measure weight, you can use spring balance. You can use top pan balance to measure weight. You can use scale to measure weight. So all these, you can also use lever balance to measure weight. But when it comes to mass, you use beam balance. Now, what Jamb wants you to know What does Jamb want you to know in this topic now? This is the first topic in the syllabus. I'm destroying it for you. I'm annihilating it for you. I'm dismantling it for you, telling you what Jamb wants you to know. Because a lot of students prepares anywhere but left is hater skater. So if you are under my mentorship, this is what you are going to be enjoying. If you want to join my mentorship, contact me. My contact is everywhere around my social media platforms. So contact me and join my mentorship. Let me mentor you and take you to the demands of this Jamb UTME 2026 examination. So you don't have to be reading textbooks. Like I said, burn all your textbooks. This is all you need. You need me. That's just what all you need is me, your pen, your notebook, your brain, your past questions and answer, and your money to buy Jamb form. Go there on your Jamb and blast 280 and above. All my mentees 280 and above. So let's continue. What Jamb wants you to know, that's what we want to look at now. This is the caveat. This is the most important aspect of this. Jamb says you should be able to identify the length, area, and volume. So length is measured in meter, area is measured in meter square, volume is measured in cubic meter. That's it. So these are what Jamb wants you to be able to identify. Number two, Jamb wants you to also know the different measuring instruments, and we just listed them before. We have meter rule, vernal caliper, micrometer, screw gauge. We all stated their uses and what they are used to measure. Okay, we have micrometer, screw gauge for length/thickness that is small, very small, micro length. Okay, micro thickness. That's when we use the micrometer, screw gauge. What the meter rule and the vernal caliper can pick, you use micrometer, screw gauge. For example, the hair, rope, tiny string, you use micrometer, screw gauge. So anytime you hear that micro, just remember that it's something very, very small. Measuring cylinder for measuring liquid, beam balance for measuring mass, stopwatch for measuring time. I also added, I say lever balance, you can use to measure weight. Spring balance directly uses spring balance, and scales such as the top palm balance and the other forms of scales for measuring weights. Number three, Jamb wants you to be able to determine the length, the surface area, and volumes of regular and irregular bodies. Let me give you the answer to it. Regular bodies such as cube, sphere, and cylinder. When you say a body is regular, it means that the body has a definite shape. It is either the shape is square, the shape is round, the shape is oval, the shape is rectangular, the shape is trapezoid. It depending on, but it has a fixed shape. You know the shape, you can see the shape. Okay, it has a shape. That's when it's regular. And for this regular body, they include such as cube, sphere, like I explained to you, cylinder. All these are shapes. You use formulas to measure these kinds of what body. Okay, you use formulas to measure their volume. Okay, and their surface area. For example, volume of cube. Volume of cube. When the shape is cubic, the volume is area cubic area. Area times area times area. That is the volume. So that's what you are going to use in calculating. This one is basic mathematics. Okay, so you have to know the area of sphere, area of cube, area of a circle, area of a square, and so on and so forth. Length times breadth. All these things is very easy. So that's that. So you now know that for regular bodies, regular shaped bodies, you use their formulas. All of them, they have their own formula. They have their own formula. So you use the formula. But when you are measuring irregular bodies, you use displacement method. When you say a body is irregular, what does that mean? It means that this body does not have a definite shape. You don't know the shape. You have never seen that kind of shape in your life before. You can't call it square. You can't call it circle. You can't call it rectangular. You can't call it cubic. You can't call it cylindrical. You can't call it any shape. That's why it's called an irregular shape. Irregular. Regular has a definite shape. Irregular has no definite shape. The shape is unknown. So what do you use in such body? You use displacement method, such as immersing it in water. Okay, you know the Archimedes principle. Immersing a body in water and using the weight. Okay, using the weight of the water, that's the fluid displaced to get the weight of the body. So you immerse it in water and you measure volume displaced. So the volume of fluid displaced, when you put the object inside a bowl of water, for example, the volume of fluid displaced, that's the volume of fluid that leaves the water bowl when it's full. When you put that body in that water, you throw them inside, to boom. The volume that displaces, the volume of water that displaces, is the volume of that body, that irregular body. As simple as that. That is the easiest method of using displacement method to measure the volume of an irregular body. That's that for that. Number 4, what Jamb wants you to know: use simple beam balance. How to use simple beam balance? Beam balance is very easy to use. One side is the weight or known weight, then one side is the standard weight. You know beam balance, that thing in court of law, that's like this. That's beam balance, that's like this. One side has a standard mass, which you use in measuring the mass of the object, while the other side has the mass, the unknown mass that you want to measure. Okay, so to use beam balance, place an object one side, standard weight on the other until balanced. So you are going to place the object one side, place standard weight on the other side until it balances. One side no can go up, one side come down. The two sides will balance, they the same height. That's how you are going to get the mass of the object. So the Bouchard's balance and chemical balance are examples of beam balance. Okay, so Bouchard's balance and the chemical balances are the examples of beam balance. They are the kind of beam balance. Okay, so the next is number 5. Jamb wants you to be able to identify the unit of mass. identify the unit of mass. So you can easily see this in your Jamb UTME question. What's the unit of mass? Because they told you that you should be able to identify it. So the unit of mass is what? Kilogram. Okay, kilogram. That's the unit of mass. Mass can also be measured in gram. Okay, mass can also be measured in gram. Mass can also be measured in weight. Weight can also be measured in kilogram. Okay, so weight can also be measured in kilogram. So you can use both kilograms and grams to measure mass and weight. So shikina. Number 6, Jamb wants you to be able to identify the unit of time. And what is the unit of time? The unit of time is second. This is it. S, second. That's the unit of time. Number 7, Jamb wants you to be able to use different time measuring device. For example, stopwatch, clock, and pendulum. So we all know how to use the stopwatch. You can read time. We all know how to use clock. That's it. That's that for that. And pendulum. Pendulum is how many oscillations per minute. Now that we have understood what Jamb wants from us, let's now look at some Jamb must repeat questions. These are the Jamb must repeat questions. Question 1. What is the SI unit of length? SI unit. What is the SI unit of length? A, kilogram. B, second. C, meter. D, Newton. Drop your answer in the comment section. Number 2. Which instrument is most suitable for measuring the diameter of a thin wire? Thin wire. A, measuring cylinder. B, meter rule. C, vernal caliper. D, micrometer screw gauge. What's the answer? Drop the answer in the comment section. Number 3. What's the SI unit of mass? The SI unit of mass, is it pounds? Is it kilogram? Is it Newton? Is it gram? What's the answer? Drop the answer in the comment section. Number 4. Which method is commonly used to determine the volume of an irregular solid? Irregular. A, water displacement method. B, using a meter rule. C, using a vernal caliper. D, using a beam balance. What's the answer? Drop the answer in the comment section. Number 5. Which of the following is a derived unit? Is it Newton? Is it kilogram? Is it second? What's the answer? Drop the answer in the comment section. Let's move over to the next topic.